Today we are going to learn about mastering Python Lambda for data manipulation. We will explore how to effectively use Lambda functions to enhance your data manipulation skills, making your code more concise and readable. Welcome to our video on mastering Python Lambda for data manipulation. Today, we're diving into the world of Lambda functions, a powerful feature in Python that allows you to write small, anonymous functions on the fly. Lambda functions are especially useful in data processing tasks, where their concise syntax can lead to more readable and efficient code. In this video, we'll explore how Lambda functions work, their advantages over traditional function definitions, and practical applications in data manipulation. By the end, you'll be able to incorporate Lambda expressions into your workflows to streamline data transformations. The first step in mastering Lambda functions is understanding their syntax. A Lambda function in Python is a small anonymous function that is defined using the keyword lambda. Unlike a traditional function defined with the def keyword, a Lambda function does not have a name. Its syntax is simple: lambda arguments, expression. The Lambda function can have any number of arguments but only one expression. The expression is evaluated and returned. For example, a simple Lambda function that adds 10 to a number would be written as lambda x plus 10. This compact syntax makes Lambda functions ideal for situations where you need to write small, throwaway functions that are not reused elsewhere. However, it's important to note that Lambda functions are limited to a single expression, which means they are not suited for complex operations. When deciding between Lambda functions and traditional function definitions, it's important to understand the strengths and weaknesses of each. Traditional functions, defined using the def keyword, are versatile and can contain multiple expressions, complex logic, and include docstrings for documentation. They're generally more readable, especially for longer functions. On the other hand, Lambda functions are concise and can be defined inline, making them ideal for short operations that are used only once or a few times. They excel in scenarios such as being passed as arguments to higher-order functions like map, filter, and reduce. However, their limitation to a single expression means they're not suited for more complex logic. When deciding which to use, consider the complexity of the task and the need for readability versus conciseness. One of the most common applications of Lambda functions is with the map function. The map function applies a given function to all items in an iterable, such as a list, and returns a map object, an iterator. By using a Lambda function with map, you can transform each element of a list in a concise manner. For example, if you have a list of numbers and you want to square each number, you can use map with a Lambda function like this: map lambda x, xx, numbers. This will apply the Lambda function to each element of the list, returning a new list of squared numbers. This approach is not only concise but also efficient, as it avoids the need for explicit loops. The combination of map and Lambda functions is particularly useful for simple transformations where defining a separate function would be overkill.
Filtering data is another area where Lambda functions shine, especially when used with the filter function. The filter function constructs an iterator from elements of an iterable for which a function returns true. By using a Lambda function as this filtering function, you can specify concise conditions for filtering. For example, if you have a list of numbers and want to filter out the even numbers, you could use filter lambda x%2 equals 0 numbers. This will return an iterator of only the odd numbers from the list. This method is both concise and efficient, avoiding the need for a loop to filter the list manually. The combination of filter and Lambda functions is ideal for simple filtering operations, providing a clear and readable way to express the filtering logic.
The reduce function, found in the functools module, is another powerful tool that works well with Lambda functions. It applies a rolling computation to sequential pairs of values in a list. By using a Lambda function with reduce, you can implement aggregation logic in a concise manner. For example, to calculate the product of a list of numbers, you could use reduce lambda x, y, xy, numbers. This Lambda function takes two arguments and multiplies them, applying this operation across the entire list to produce the final product. This approach is efficient and eliminates the need for an explicit loop to perform the aggregation. The combination of reduce and Lambda functions is particularly useful for implementing simple aggregation logic, providing a clear and compact way to express such operations.
Lambda functions are also highly effective when working with data frames and pandas, a popular data manipulation library in Python. Pandas provides the apply method, which applies a function along an axis of the data frame. By using a Lambda function with apply, you can perform transformations on your data frame in a concise manner. For example, if you want to increase every value in a column by 10%, you can use df column_name. Apply lambda x1.10. This Lambda function is applied to each element of the specified column, transforming the data in place. This method is not only concise but also leverages the optimized performance of pandas. The combination of the apply method and Lambda functions provides an efficient way to perform complex transformations on data frames, enhancing both readability and performance in data manipulation tasks. While Lambda functions offer the advantage of conciseness, maintaining readability is crucial, especially in collaborative projects. One best practice is to balance the use of Lambda with traditional functions, reserving Lambda for simple operations. Adding comments can also enhance readability, explaining the purpose of a Lambda function when its intent is not immediately obvious. For instance, if a Lambda function's logic becomes too complex, consider refactoring it into a named function for better clarity. Avoid using Lambda functions where the logic involves multiple steps or is not easily understood at a glance. By following these practices, you can ensure that your use of Lambda functions enhances, rather than detracts from, the readability of your code. While Lambda functions are powerful, they come with potential pitfalls. Overusing Lambda functions can lead to less readable code, especially when the logic becomes complex. Lambda functions are also limited to a single expression, which can lead to convoluted logic if pushed beyond their intended simplicity. Additionally, debugging Lambda functions can be challenging, as they lack the clarity of named functions with multiple lines. To avoid these pitfalls, use Lambda functions sparingly and only for simple operations. For more complex logic, opt for traditional functions with descriptive names and multiple lines. By being mindful of these challenges, you can leverage Lambda functions effectively without compromising code quality.
In conclusion, mastering Python Lambda functions can greatly enhance your data manipulation skills. We've explored their syntax, compared them to traditional functions, and demonstrated their use in conjunction with functions like map, filter, and reduce. By incorporating Lambda functions into your toolkit, you can write more concise and efficient code, particularly in data processing tasks. Remember to balance conciseness with readability and avoid overcomplicating Lambda logic. We encourage you to practice these concepts in your own projects and continue exploring Python's rich ecosystem. Thank you for joining us, and happy coding!